My name is Zygmunt Strawczynski. You can call me Zygmunt, whatever is easier to pronounce. And with me today is Jesse Gadzanowski, and we work with Enbridge Gas Distribution in our energy efficiency group. And we're going to be speaking to you today about how to identify gas-saving opportunities in office buildings, how to put projects through, and the available help from Enbridge Gas for those projects in the form of financial incentives and free consultative services. We have an hour and a half to speak today. This is just a quick breakdown of the topics that we will be discussing. Just ground rules for this talk. If you have questions that come up at any point, just raise your hand and we'll try our best to answer them on the spot. This is a fairly small group, so I think we'll have a pretty good amount of flexibility in terms of timing. But yeah, basically we're going to go through a few key components. We're going to spend a bit of time on Enbridge Gas's territory and why we deliver programs to help customers save gas when we're selling them gas at the same time. We're going to talk a bit about the the acquisition of Spectra Energy, which includes Union Gas and the future of gas distribution in Ontario, which some of you may be wondering about. And then Jesse will walk us through the big drivers of gas consumption in office buildings. And then I will go through how we can help financially incent or provide other services to lower the consumption in those buildings. And finally, Jesse will walk us through three pretty interesting case studies of projects that we have participated in with major office customers. And at the end, something a little different, we're going to talk a bit about cap and trade and the new reality that we all live in Ontario and how this affects both gas bills and the equations of energy efficiency and the business case for pursuing gas efficiency projects. So Enbridge Gas Distribution is the single largest dedicated natural gas utility in Canada and one of the largest in North America. We serve over 2 million residential customers, basically bucketed into three main areas on this map. So the areas in red that you see, the Greater Toronto area, a bit of the Niagara region as well into St. Catharines, and then the Greater Ottawa area are all Enbridge territory. So what we'll be speaking about today has to do with office buildings that would be served by Enbridge Gas in those three major regions. I should say as a side note, if you are doing work or have customers or are a gas customer in anything that is in the blue region, which is Union Gas's territory, a lot of, or if not everything that we are speaking about today will also be available to you in Union Gas's territory. They have very, very, very similar programs available to their customers as well. The composition of their customer makeup for commercial and industrial is very different from Enbridge Gas, specifically because we have the two major population centers of Ontario in our territory. It results in a lot more in the way of multi-residential buildings and a lot more in the way of like large office towers than Union Gas, which serves a lot more in the way of like warehouses, distribution centers, and industrial customers. You see this blue line snaking through Ontario, basically following the Trans-Canada Highway. That is one of the major pipelines that brings gas into the province from out west. The other, which is not focused on this map, comes through Sarnia in the southwest of Ontario through something called Dawn, which is one of the major distribution hubs for natural gas in the province. And the other major pipeline basically snakes underneath the 401. All the way through the rest of the province. And from that, you have tens of thousands of kilometers of distribution pipelines serving every gas customer, millions of them across the province. Enbridge serves 160,000 commercial and industrial customers. Union Gas serves a similar number as well. I will say, as I mentioned earlier, so you may have heard in the news over the last couple of years, Enbridge Incorporated, which is Enbridge Gas Distribution's parent company, the large oil and gas company based in Calgary, last year acquired Spectra Energy, a large diversified oil and gas company based out of Texas. One of their holdings in this $37 billion acquisition is Union Gas. which is the province's other major gas distribution provider. Between the two of us, we serve, it's like 98 or 99% of all buildings in the province. And we have just filed with the Ontario Energy Board, which is our regulator, to begin to merge operations with Union Gas. So it's unclear. I can't say whether it's all going to come under the Enbridge banner or whether Union will still be branded as Union Gas. It's going to be a long, multi-year process. There are a lot of moving parts to this. For the purpose of energy efficiency, which is the topic that we're speaking about today, our programs still operate separately from Union Gas's, and that will continue until the end of this particular program cycle, which is 2020. And in 2021, it's possible and probable that our programs will be filed jointly, resulting in one unified program on the gas side, province-wide, which would make life a little bit simpler. Any questions on that? Yep.
So pretty much all these different companies are going to become just one.
Yeah, there's only two, and they're going to become one, exactly. On the electricity side, our territory overlaps with dozens of electricity providers, so Toronto Hydro, Electra, Niagara Power Energy Company, Hydro Ottawa, et cetera, et cetera. There's over 70 different electricity providers in the province of Ontario. And as we'll show later on, depending on the projects you're doing, where there's savings opportunities for gas and electricity, you can and should apply for all available incentives for all fuel types. So our mission in the demand-side management world is to advance the energy efficiency and sustainability goals of our customers, of our gas customers. And you may be wondering why Enbridge Gas actively encourages its customers to use less of the thing that it is selling to them. And there are a couple of very simple reasons for this. Number one, we are regulated to do this and told to do this by the Ontario Energy Board. Ratepayer money is pooled by our regulator, and some of it is held in trust for the purpose of delivering these programs. And we provide a lot of this money back to customers in the form of financial incentives to help lower their gas consumption and subsequently lower their greenhouse gas emissions as well. Enbridge is also financially incented to deliver these programs. We can realize a shareholder return if we hit our savings targets year over year. And the reason that is not in conflict is that Enbridge Gas does not actually make profit by the volume of the commodity that we sell. If you think about it, it makes sense. In a cold winter, like the one that we had a couple of winters ago, it was 2 or 3 winters ago, where it was like minus 20, or so, it didn't get above zero at all in the month of February. You're using more gas than you otherwise would in another February. And where else are you going to get heating fuel? It's not exactly fair. Enbridge operates as an effective monopoly in the territory that it serves. So it wouldn't be fair if Enbridge made more money just because it's colder and these circumstances are out of your control. Enbridge Gas makes money by operating a safe and efficient delivery network for distribution of natural gas. And we are tied to very specific KPIs from the Ontario Energy Board according to customer care, delivery, efficiency, etc. So it's actually in our interest as well to help customers use less gas because it helps us do well financially, and it can also help offset some of the infrastructure requirements that could be slated in the future. So for example, if we're helping to retrofit a series of office towers in a particular sector that are served by a single distribution pipeline, that can actually be a cheaper solution for us than digging up the ground and putting in a larger pipeline to accommodate more load on the system. Make sense? Cool. And the way that we do this, and we've done this for over 20 years, is through a few different services and programs that we provide. Primarily, we engage commercial and industrial customers of all stripes, all shapes, all colors, etc., in education and awareness, not just in how natural gas is consumed in your buildings, which Jesse will speak to specifically about office towers, but also what Enbridge can do to help you manage that energy consumption and lower it for the purpose of reducing GHGs, lowering your cost, and being able to free up money to go into other things. Everything we do is free, absolutely everything. We work with customers directly, we work with engineering firms, we work with consultants, we work with distributors, we work with manufacturers. We are agnostic to the market, meaning that we insert ourselves into a retrofit decision or a project scoping or whatever it is, whatever stage of a project, in whatever way is most comfortable to the parties already working in that. We can provide supplementary calculations, consulting services, free advice, modeling tools, and money, free money, basically, towards whatever ends up getting done. And we reduce the amount of gas going through our system through these programs by about 1 to 2% every year is saved by delivery of these programs across residential, commercial, industrial. We've saved a tremendous amount of gas over the course of delivering these, 235 million cubic meters of gas. 1 cubic meter of gas produces 1.8 kilograms of carbon dioxide when it is burned. So you can do the math as to the environmental impact that we are helping to provide. So as I mentioned, we have over 160,000 commercial customers. And the way that we approach the market is a little different from Union Gas, but the way that Enbridge Gas approaches the market is by vertical. So we segment our customers according to the building type. And by and large, it is a clean process. We include multi-residential buildings in our commercial industrial program. So if any of you are working with property management firms or for a property management firm that doesn't just deal with offices, our C&I programs touch multi-residential buildings as well. So anything that's covered under Part 3 of the building code. Offices, obviously, everything from a one-off in a smart center to the largest office towers in the city of Toronto or Ottawa that are managed by institutional customers like the government or the largest REITs and other property management firms. Retail, everything from the smallest shopping mall and strip mall and like one-off Canadian Tire to the largest like Yorkdale and other large shopping centers. Education includes primary and secondary education across every school board that would be touched in our territory. Municipalities is pretty self-explanatory. Every municipal building, rec centers, office towers, water treatment facilities are a gigantic user of gas. Warehouses and distribution centers, we have thousands of those. Food service includes everything from restaurants to grocery stores to specialized like food preparation centers, hotels, motels, and also long-term care facilities, which are substantial users of gas as well. And Jesse is now going to talk a bit more specifically about office buildings and the office sector and our customer base in Enbridge territory.
Thanks, Zig. So I am the Commercial Energy Solutions Consultant for Enbridge Gas. I work with all of our customers and business partners to deliver energy efficiency programs in the market. We do it in two ways, working through our key accounts and our business partners. So the key accounts are representatives of the building owners or the property management companies that are operating the buildings in the field. We have programs that I try to get into the C-suite and deliver. So once we get the CEO, the CFO, the COO, we get them involved and supportive of our programs, then we can filter that down into the operations team. Usually I do the meat and potatoes with the operations team, do site visits, gather information for specific retrofit projects, and then quantify gas savings for the projects based on base case and proposed inputs. So we work with owners, but then we also liaise with business partners in the field. We have roughly 40 or 50 firms, whether they're engineering firms, mechanical retrofit companies, HVAC companies, or energy services companies. These are entities out in the market who have vested interest in helping their customers save energy. So it's a very good avenue for me and us to liaise with these groups. They generally bring projects in, and we work with them to put the incentive amount on the bid or any proposal that they're giving to an owner. So we serve roughly, I serve personally roughly 2,000 to 3,000 buildings in the GTA and Niagara. We do have an Ottawa component, like Zig said, but we have a separate ESC consultant out in Ottawa. So it seems like a lot of buildings, but not every building's doing a project every year. So we have 50 to 100 projects generally every year that we are working on. So it's manageable. Next slide, please. So today we're going to talk a bit about how gas is used in office buildings, and then look at common technologies for those uses, and then also identifying savings opportunities in office buildings. So typical use, offices are very complex buildings. You can have the 50-story mega building with a lot of interactive systems, but on the heating side, generally it's relatively simple. We have heating, domestic hot water, some cooking, and some other loads. Could be ramp heating, humidification, natural gas dryers, things like that. So it's not a very complex thing on the heating side, but there are components that do make it difficult depending on the interactive effects with other systems. Generally, we're finding in large office buildings, boilers, either hydronic or steam, using gas. These systems are serving generally perimeter rads or some perimeter induction units or fan coil units, things like that. Those systems generally will serve the air handling units. A lot have central compartment units that serve the floor level compartment units, and those might serve variable air volume distribution points or, like I said, induction units, things like that. You might have rooftop units with individual coils or their own burners for smaller office buildings, B and C classes, and sometimes less so. You'll have the indirect fired makeup air supplying 100% outdoor air. That these are in the field as well. In Toronto Metro specifically and Markham, we also have district energy systems. So Enwave serves a lot of the big office towers downtown. I'm not sure. So what do we have in the room here? Do we have owners and property managers? Hands up. Energy services companies, mechanical engineers. Okay, so we got a mix. So Enwave serves for the owners. They serve steam. They burn gas at their Pearl plants and the Halton plants. They use gas to generate steam. That steam is then sent to customers in the Enwave network. So we provide incentives and technical support for Enwave as well, so we can quantify how much gas would be saved in an equivalent pounds of steam. So we work a lot with Enwave here as well. So those are the most common things you're seeing. If you don't see something and you've got something in your mind up there, I'm sure there are a few, but that's what we're seeing out in the field now. Next, please, Zig. So how do we save gas in these types of systems? So for, on the top left there, hydronic systems, generally we're looking at boilers. Enbridge's bread and butter has been for the last 20 years is boiler retrofits. We probably do around 75% of our gas savings business through boiler retrofits. And I would say most owners and people out in the field recognize that we have, for sure, a boiler program. And then they know somewhat about other layers like ventilation and things like that. But so boiler upgrades are a big one. System upgrades in terms of piping, a lot of the times we're seeing in the field that some older systems still have that primary direct return system where all of the hot water is being pumped through the boiler, and the boiler essentially acts as a big radiator. So a good upgrade for these types of systems is simply going to a primary, secondary, or an intermittent pumping situation where you're limiting that heat loss in the boiler systems. For steam systems, we're seeing a lot of steam trap replacements and steam trap jackets. Essentially just limiting those leaks. Depending on how many steam traps you have in a facility, there can be a substantial amount of leaking steam, which is actually a very large loss. And you can have easily 100,000 cubic meters coming out of a large building just in steam leaks if you haven't really maintained that system appropriately. Steam trap jackets, it's kind of a newer thing that we've been promoting. It's just essentially putting a 1-inch piece of insulation layer around your steam trap, because the steam trap is essentially an exposed piece of pipe with 200 degree Fahrenheit steam in there, so it's just radiating heat. So it's the steam trap jacket you can put over it and just contain that heat loss. Heat exchanger replacements, there are a few going on this year. It's a good one. A lot of heat exchangers are old and they're not really doing much with the condensate for a lot of systems. So a lot of the times the condensate will be sent to a quenching tank. The temperature is reduced a bit, but then you just dump it down the drain and all that heat's lost. So some heat exchanger retrofits are happening this year where you can have more of a flooded unit where you're subcooling, you're using some of the BTUs in that 212 degree Fahrenheit condensate. Maybe you can bring that down to around 180 F before you have to quench it. So the delta between that 212 and 180, you can capture that and put it into your domestic hot water, or you can preheat the incoming water for whatever you would need it for, really. Condensate heat recovery, again, putting that into domestic hot water. So controls upgrades, we're looking at burner retrofits, going from a single stage or a two-stage burner to a modulating burner. Simple control upgrade can save a substantial amount of gas. Linkageless controls for steam and hydronic boilers, getting a more digitized output for your air-to-fuel ratio. It's a good opportunity to save gas as well. Connecting any systems to the BAS, we find that a lot of older systems are still standalone and not really working with the building together. So connecting to the BAS is a good opportunity for upgrades. And then doing nighttime loop temperature setbacks, finding that in a lot of multi or mixed-use buildings, there are retail components of the building that have a 24/7 operation, say a Rexall or a Tim Hortons or something like that. So the building's supplying heat to the entire building and only to satisfy that one zone. So it's kind of rezoning, doing some night temperature setbacks and letting the building cool down a bit and only heating up those 24/7 zones. So it's a good opportunity there as well. For ventilation, we're looking at VFDs, demand control ventilation, nighttime setbacks again, optimal start-stop programs. So once you connect to the BAS and you try and tighten that on-off time between, try to shave an hour in the morning or maybe shave an hour in the evening. There's a substantial savings there as well, especially if you're doing it over multiple rooftop units or multiple systems. And ERVs and HRVs. I've had a big project this year where we did around 34,000 CFM of incoming air. They put a couple of heat wheels on. There was 2 units, and I think they're saving, upwards of 75% of the gas that would have been needed to heat up that incoming air just by having the heat wheel on there. So it's a good opportunity there as well. Although some challenges for sure in operations because ERVs are prone to breaking down or being operated not optimally. So anyway, it's an opportunity. For steam systems, already went through that. And then operational side, outside of the capital retrofit, just tweaking your building on the operations side to get it performing better. Scheduling your equipment, doing sensor calibration, say your CO2 sensors need to be calibrated or your pressure sensors in your ducts need to be calibrated, things like that, so that the air is being supplied as you would. Outdoor air optimization, equipment operator and temperature set points, making sure you can get your set points where you need them. If they're not drifting, making sure that the building's operating appropriately. And then we can do all those things, bring in an engineering company to do all those things for you. But at the end of the day, we would also need the operators to understand the changes. So we provide help for operator training as well. Next, please, Zig. So domestic hot water, the second chunk, if you remember from the pie chart, only around 10%. In office buildings specifically, it's not a large concern generally. I go into a lot of buildings and the systems are, the heating systems are brand new, the BAS is brand new, but you'll have still like a 25-year-old boiler for the domestic hot water just chunking away. And they're like, well, it's working fine, doesn't really need a retrofit yet. But it's really, if you're consuming 200,000 cubes in a building and you're only at like 10 or 15,000 cubes of that is domestic hot water, it makes sense that it's not the biggest point for the retrofit. Typical office domestic hot water end uses, we have bathrooms, kitchens, showers, and janitors' closets. What we're seeing mostly for supplying heat to these loops is single hydronic boilers with storage capacity, or maybe you'll have a combined heating and domestic hot water plant with a heat exchanger, or even just high efficiency water heaters, which is more common, I'd say. Next, please, Zig. So similar to the heating side, for hydronic systems in the top left, you're looking at just boiler upgrades, getting your thermal efficiency as high as possible, insulating the storage tanks, instantaneous, hot water heating. You don't need a storage tank. You just put in the instantaneous heater, seeing that more and more. Or even some of the more proactive guys are doing, and people. So yeah, some of the more energy efficient people are doing actually hybrid solar collectors for domestic hot water and offsetting gas that way. It's a more expensive approach, and the paybacks are incredibly long, but we see that out there. For steam systems, like I said before, a lot of condensate heat recovery to domestic hot water. It's a good opportunity. Controls upgrades, same thing, connecting to the BAS, doing some setbacks if you can. Maybe in the daytime, if you've got a large tank and you know your demand's high in the day, so you need to have that water at 150 to maintain the load for the day. But at night, you're not going to need a tank full of 150 degree water. You could probably drop that down maybe 5 or 10 degrees Fahrenheit just to meet the overnight load, and it would be appropriate. So a little bit of savings there. On the distribution loop, you can install mixing valves, so you can only supply a certain temperature of water to the tenant spaces. You don't need it to be blistering hot. Or VFDs on the distribution pumps can save a little bit as well. Operationally, we have similar types of things, nighttime setbacks, sensor calibration, all the same stuff I said before. So Enbridge helps with that as well. Next, please, Zig. So the top trends we're seeing that I worked on this year, like I said, boilers, bread and butter, it has been, and it probably will continue to be until gas is gone. We have seen a lot of steam trap replacements. We do year-over-year replacements. So if any of your systems aren't operating with steam that is not leaking, give me a shout, let me know. There's a good opportunity for savings there, and Enbridge generally supplies a lot of the incentive. Right now we're doing up to 20 cents per cubic meter on a steam campaign, so we're going to get a lot of the steam trap replacement costs paid for. Steam trap jackets, like I said, the insulation piece, that's been new this year. I'll go over a case study of that in a building last year in a bit. Rooftop unit replacements. A lot of owners are doing kind of national programs where they'll say, okay, let's look at our whole portfolio and let's replace all the rooftops chunk by chunk or region by region. And a lot of those actually, even in big office towers, are still electric and they want to go over to gas. So that's been a big retrofit opportunity now. The thing about that, though, is that people would like an incentive just for a rooftop unit, saying, we're going to go to a gas unit, what are you going to give me? And I can't say right away, I can give you $500 like the electrics can. We can say, well, it depends. It depends on two things. Are you going to vary the amount of outdoor air coming into the building with a VFD? If the electric unit doesn't do that, are you going to improve that outdoor airflow so you can reduce the amount of heat needed in the building? Are you going to control for demand? Are you going to do demand control ventilation sensors and control it that way? Or you can do any type of start-stop scheduling. So we need to either lower the flow of incoming air or reduce the schedules if you're going to see any gas savings from going to electricity, from electricity to gas. Heat recovery chillers, it's kind of been under the radar, but I think a lot of deeper pocket customers are looking at that more closely in the next couple of years. Especially for buildings that have simultaneous heating and cooling in the winter. And you can't offset all of your heating load or your cooling load with free cooling, and you have to run the chiller in the winter. So we're finding now that there are technologies in the field that provide a lot of low-grade heat. You might get heat recovery from a chiller in the range of 90 to 120 degrees F, and that's good for certain capacities, but you can't really meet your heat load with that. Some companies out there are adding an extra compressor onto the chiller package, and then spinning that compressor and getting that low-grade heat up to high-grade, so that you can actually use the chiller to chill where it's needed, but then offsetting a large part of your heating load with the chiller. So it's an interesting upgrade. If you'd like any more information on that, please talk to me after, but it's a good opportunity. Flooded heat exchangers, like I said, subcooling that condensate, using more of that heat, it's a good opportunity. And then operational improvements. We have a Run It Right program, which I will talk about later, but a lot of buildings now, they've done a lot of the large retrofits, especially the A-class, everyone's got everything done, all the new systems are there, things look great, but how do we make sure the building's gonna operate consistently and well over time? So that's what we're seeing, people coming to us for operational improvements. That's a good segue into BOMA and the race to reduce. So I don't know if anyone have buildings involved in the race? Yeah? So for 2017, it started this year, and Toronto Hydro is the key sponsor for that, and it's heavily focused on the electricity side currently. But realistically, if you're going to reduce, they're looking at a holistic approach. They want to see electricity, gas, water, and even waste, I'm hearing. So we currently are a contributing sponsor to this race, but next year we're going to be more heavily involved because we want that gas piece to be right up with the electric, saying, hey, if you're going to get 10%, let's do it holistically, not just with electricity. So next year we will be heavily involved. So if you've got buildings that you think there are gas savings and you want to get more increments to that 10% for the race, Enbridge will be involved in that heavily. So more on that to come. So I think that's going to segue over to Zig and talking about what we offer for incentives.
Yeah, thanks, Jesse. So I'll spend 20 minutes talking about, Jesse's done a great job going through the key drivers of gas consumption in office buildings. Now I'll talk about the money, which is, let's be honest, that's what we're all here for, and how you get it. So we offer financial incentives and other free services to the market. For the purpose of this presentation, I'm going to focus on commercial and office buildings specifically. And the first two things you see, which is prescriptive and custom. And what that means is two different streams for getting financial incentive from Enbridge Gas for retrofit of any kind that will quantifiably lower the gas consumption in a building. We do also have a very limited audit program available, HVAC audits as well as steam trap audits and replacements. And Jesse will speak a bit about Run It Right, which is our operational low cost, no cost savings focused program later on. So we offer prescriptive incentives for a good number of kinds of technologies. And before I sort of list off some of the ones that we offer, what that means is it's a straight rebate style application for an incentive from Enbridge Gas. And what it involves is, and I'll show in a couple slides, you essentially install the equipment that is listed in our brochure or anything that's on here, and this is not even an exhaustive list. You put the equipment in, you fill out a one-page fillable PDF, so you can fill it out on a computer, you can print it out, you sign it, you send it to Enbridge, we process the incentive. Some of our contractors don't even fill out the whole thing, they just give us the install address and the equipment information, and we can follow up with the customer and complete the application on their behalf. There's a wide range of technologies that are covered through this program. Some applications of condensing boilers can go through this, make up air units, destratification fans, heat recovery ventilators. For some other specialized applications like infrared heaters are very useful for warehouses, but air doors can be useful, or pedestrian doors at the entrances to commercial office towers. And then obviously there's some space heating, or sorry, some water heating applications as well. And then in the kitchen, if in an office building you have kitchen equipment, we offer fixed and rebate style incentives on a number of different measures. Broilers, dishwashers, fryers, demand control kitchen ventilation, so intelligent control strategies on the range hoods of kitchen or food prep areas. That is a surprisingly large driver of gas consumption because you're sucking out a lot of conditioned air that then needs to be replaced by newly heated air coming in. Those systems can cost over $10,000. We offer up to $5,000 per system, depending on the CFM that is being installed. And if you're building a new office tower, while this is not the focus of today's presentation, but if you're building a new office building, 90% of the technologies that we provide incentives for in our retrofit side can also qualify if you're putting in some of this equipment in a new build. And the reason for that is if you're going above and beyond what the market would deem acceptable or what is the minimum of building code, you're going to lower the expected gas consumption of that building, and we will provide financial incentives on that as well. The big exception is boilers in the new construction application, but all the other technologies I've listed off, and there's more that aren't included on the slide, would be covered in our new construction stream. So that's one of the ways that we provide financial incentives. You have a brochure, or you find it on the Enbridge website, it's a PDF, you say, aha, I'm putting this in, you put it in, you fill out the application, you send it to Enbridge. It's a very, very easy, straightforward process. We do not have a formal pre-qualification application like you would if you've ever used a Save on Energy project before, where you have to, I believe it's fill out a formal application to the electricity utility, wait for them to review it, and then say, yes, we can proceed with this. We do this in as little as like a phone call or an email, just to know what's going in. Or in the case of our fixed program, if you have the brochure and you're looking at it and what is listed there is what you're installing, and you turn it over and you meet the terms and conditions, which are few, honestly, for the kinds of tech that we have, that's it. That you just put it in, you will get the incentive, no question. The other way that we provide financial incentives is through our custom stream, and this is for more complex projects. So any kind of technology that's not covered under our prescriptive approach, or anything where there's interactive effects, as there often are in office buildings, or we need to quantify the gas savings from the technology being installed and what it's replacing, or how the building is retrofitted, we would model out what the expected gas savings are and quote a financial incentive based on the expected gas savings annually in that building. We do have case studies that we'll go through, and I actually have a sample calculation even before we get to that of how we deliver that savings approach. In that approach, and it's like 80 to 90% of the projects that we do, and probably more than that in the office sector, are custom. So it's where you call up Jesse or you email Jesse early on in a project and you say, hey, I'm thinking of putting in a new boiler into this building that we run, or we want to do rooftop unit replacements, or we want to address our domestic hot water load. You would simply get in touch with Jesse as early on as possible, and depending on the size and complexity of the project, the information that we need can be collected over the phone in terms of equipment specifications, both existing and what's being scoped for install, or at the customer's behest, or depending on the amount of information we need, we would also schedule a site visit. Come in, do a walkthrough, collect everything that we need to do the calculations, but also help identify other opportunities for gas savings that you maybe aren't considering that we can provide incentives for. Any questions on that so far? The question is, are there typical circumstances under which you would apply for fixed versus custom? The best approach, I would say, is to simply call or email Enbridge as soon as you're considering a project, and we'll speak about why you should do that early on first, or later on.
Can I add something there?
Yeah, absolutely.
I think if you're going to do a piece of equipment in and out and not change anything else, and it's in the fixed side, that's probably your best bet. But if there are going to be any changes to piping or scheduling or anything like that, any kind of multi-measure projects, you're going to want to go custom.
And then, as I said, the majority of the projects in office buildings are custom. The prescriptive program really applies to every building type, but more volume in terms of projects typically comes through from different kinds of buildings. So food service locations, warehouses, those kinds of buildings typically do large volume. And this program is typically designed for those kinds of measures where, for an example, in a single warehouse, you might be putting in 10 destratification fans or 30 infrared heaters. Rather than, putting through 30 separate projects, you're able just to fill out a one-page thing. And we process thousands of, pieces of equipment a year that we provide incentives for, so it's easier for everybody. So the process is very straightforward, and I should stress, if you have questions or you're considering something where you think there maybe is application for gas savings, the simplest and best thing to do as early on as possible is to simply contact Enbridge Gas. Our contact information will be at the end of this presentation. You can also find it on our website and on our brochures. As I said, the fixed side of things is mindlessly simple. Install the equipment, fill out a one-page PDF, send it to Enbridge, we do the rest. On the custom side, call Jesse or call me, and we'll help you out from there. That's it. We'll take it from there. There's no hoops to jump through in pre-qualification. I like to jab at the save on energy side of things, but yeah.
Question.
But you're in the interest of the Toronto Hydro or Electra, wherever you are, are you able to give us the electric savings that occur from that equipment so we can get their money as well?
Yes.
Okay. So
Yes.
that
You're beating me to the punch.
We can give you an estimate, what we would estimate through our calculator, but you would have to go
still
through.
have
Yeah,
to-
they would-
Yeah.
going to.
They would have to. You would still have to get them involved to get the actual
Because they
amount.
need pre-approval and
Yeah.
there's a little bit more.
But you should
Okay.
absolutely. If you were sitting at a table and there were two piles of money in front of you, one labeled Enbridge, one labeled like Toronto Hydro, why wouldn't you pick both up, right? Like
But
absolutely.
They don't make it as easy as.
They don't make it as easy. They hide it or move it around or
No.
But you should absolutely make every effort to collect as much as possible in the way of incentives to shorten paybacks and strengthen the business case of retrofit projects.
That's because that new motor on that boiler.
Exactly.
and so
Boilers, control systems often have dual fuel savings applications, variable frequency drives, demand control ventilation systems, a whole host of other applications that Jesse could list off far better than I could. So in the custom side, which is where a lot of the projects in office buildings would take place, we would calculate a financial incentive and we would quote you how much to a dollar you could get back based on the expected savings that we would model. And the back end for that calculation is this. We structure our incentives to provide more to customers for going deeper into their buildings to find more in the way of annual gas, like savings in gas as a percentage of the annual load of gas. So we can look in our system and see what the historical consumption of a building is and model out based on the expected install of equipment what the delta in the reduction would be and what percentage of the building's consumption is being saved. And for the way that we do this, and we haven't done this before 2017, but we did this from looking at our project's history and saying, while we're talking to an office property manager, a building owner, wherever, we want to be able to say the more you do, the better this gets. And the next slide sort of shows how this works, but essentially for any project, let's say you're putting in a boiler and it saves 9% of a building's annual gas consumption, we would pay out 10 cents per every cubic meter of gas that building is saving. But if the boiler, let's say, saves 15%, well, for the first 0 to 10%, we pay 10 cents, and then the next 5% get twice as much. And then anything above that, when you tier this all together, it gets 20 cents, and what you end up with is a much higher payout. And to illustrate that, do you have a question?
Finish your point and I'll bring it down.
Sure. So here's an example of how that works. This is a multi-residential building, but let's say it's an office building for the purpose of this. They're putting in a new makeup air unit, and they're tying it to a variable frequency drive that they want to use to control it and lower their gas consumption. So this building uses over 227,000 cubic meters of gas a year. It's a pretty good consumer. And they're going to lower their consumption by over 21% from putting in these new measures. So that's a pretty healthy project. They're going to save 50,000 cubic meters of gas a year. If you're paying, let's be extremely generous, even though the rate's not this, but if you're paying 10 cents per cubic meter of gas now, that's like $5,000 a year of savings right off the bat that you can then figure out your recovery time for. So Enbridge comes in, you call up Enbridge and you say, hey, I want to do a makeup air unit. I'm thinking about maybe tying into a VFD. What can you offer me? My payback is 6 years, let's say. I know there's money available on the electricity side, but what's available on the gas side? So we would look at this and we'd say, well, you're going to save over 20% of this building's annual consumption. And the table at the bottom is basically what we would generate, and we would sum all of those numbers together, and we can provide almost $8,000 towards this project. So the important thing here is, in the past, we would have just said a straight 10 cents per cubic meter of gas, no matter how good the project is or what you're doing. And that would have been $4,900. So we're offering like $3,000 more under this new incentive structure. And that difference can be the difference between deciding to do the VFD at all, for example. So it really does encourage customers to go deeper into their building. And I would just say, when you have a free consultant coming out to talk to you about a project you're already considering, why not look at absolutely everything gas side in your building while he's there? You are financially incented to do so now, and maybe you decide we're just going to stick with this, but maybe this opens up other possibilities into the next year. You might be wondering if you do several separate projects in a year, like you do a boiler and then you come back and you do a makeup air like 6 months later, etc. Whether you would be able to blend those all consider them as one project to get the maximum incentive. The answer is they would be treated as separate projects, if I understand this correctly. We encourage you to do as much as possible at once. And we would put, because the base consumption of a building changes every time you change something, and then we would have to rebase and remodel according to what you're doing. So if you put in a boiler and it lowers consumption, the percentage of savings that a VFD is going to provide are smaller because you're changing the base load of the building. Yep?
This is on a bundled set of measures.
This is bundled.
So it's not that you pay out on each individual piece of equipment.
We pay on the gas savings holistically, yes, per project. So if these were two separate projects, we would calculate separately.
Yeah, so we're going to talk about 3 case study projects, 2 custom retrofits, and then 1 operational retrofit project we worked on. This one was finished late 2016. It was Rogers, the Brampton 8200 Dixie Brampton Center that they have there. So this is a multi-year program. It was kind of, Rogers has a national approach to rooftop units, and this kind of came under that umbrella. And we helped them with technical support. We did a lot of the site visits and figured out what would be the best solution for these rooftop units. They wanted to go from electric to gas, like I said, typical retrofit that we're seeing. And they had 113 rooftop units and a couple of makeup air units that they wanted to tie into the BAS, put it all under demand control ventilation, where the units before were single zone onboard controllers that were on thermostat settings and then a 12-hour timer. So significant savings there, a large project. They put motorized dampers on the new units so that they could control for the carbon dioxide, and then tie that into the BAS. So you could see what you were going to do. It was all there on the BAS output screens. And for this, the project was $1 million. We estimated that they were going to save around 470,000 cubic meters of gas. This account was, north of 1.5 million cubic meters per year, so it's a substantial opportunity for them. They had an avoided gas cost of, almost 120,000 per year, and we maxed out our incentive at $100,000. That's the most we can pay. So this was a great project. If it was on the tiered rate, they might have got more than that, but when we max out a project, we do the big check presentation and stuff like that. So this is a great example of what you can do with rooftop units. When you're replacing that many, the savings are going to be very good. The incentive will be very good. If you've got like a single or 2 units in a building, it's a good opportunity to save, but sometimes the metrics aren't there financially when you're trying to compare it to some electrics. But anyway, rooftop units, electric to gas, a good one. Next, please, Zig. This one was on the steam trap jackets. So not a lot of people are familiar with these. Some operators are and some owners, but Cadillac Fairview went ahead last year and did all of the TD towers for all of their steam systems. And they basically were interested because they have over 500 traps in the building. And if you multiply out the losses, it was substantial. Sorry, I said over 500. It's actually 814. We've got this thermal conductivity chart here, which basically shows the insulation values or properties of the jackets themselves. So you put that into a heat loss calculator here. You can't quite see, but it basically compares the BTUs per hour per foot for a bare steam trap, or we kind of take a steam trap and we say how much surface area is there for that trap. We convert that to an equivalent pipe length and say that's your bare pipe. So you've got 400 BTUs per hour per foot for a bare pipe, and then with the insulation you've got 37 BTUs per hour per foot. So a decent savings per trap. Like I said, this was a large project for Cadillac Fairview. The total project cost was around 100 grand. They saved 105,000 cubic meters of gas. We gave them in total a $14,000 incentive, and the payback was 3.2 years. For 814 traps, the numbers look great, but most steam systems out there, you're seeing like 30 traps or 20 traps, things like that. So this is like a great number, but I'm not sure if you guys are dealing with steam, but the incentives are good when it's that big, but it scales. So next, please, Zig. The third one, Run It Right. So this is our operational savings program. Like I said before, a lot of the big office buildings downtown, they've done a lot of the systems, a lot of the capital retrofits. So there's a lot of interest right now in improving the buildings operationally. The race to reduce that I talked about will be focused primarily on operational savings as well. So we expect or hope that we can help drive the race to reduce buildings in gas savings operationally through the Run It Right program. So this is our program where we try to bring in, if there's no engineer for the building, we can assign an engineer that we're working with. Or if the building has a relationship, the owners have a relationship with an engineering firm or an energy services company, that company can be our efficiency partner. So on this one, HTS was the efficiency partner. They went into this building, 515 Spectrum Way, for Triovest. We have an Enbridge checklist where HTS is given $1,000 to do the audit. There's an Enbridge checklist to say, here's all the things that you could do in the building to improve operationally. They went in and audited and found that they could improve the boiler sequencing. They resequenced supply air temperature resets for the makeup air and the air handling units. They resequenced pumps to ramp up and ramp down on pressure control. They were drifting a little bit, so there was opportunity there. AHU sensor calibration and static pressure, just checking the pressure sensors in the ducts, making sure that they're calibrated correctly. And then they also trained the operators. They explained all the changes to the BAS that they made and ensured that those changes would be maintained over time. So there was some money for operator training there as well. So to the customer, they receive the maximum incentive for this program, which is $10,000. They would pay HTS for the audit, and then they could invoice back to Enbridge $1,000 for that audit, so they can get $1,000. The implementation of all the measures is they maxed out at $8,000, and then they also put on the customer EMIS. So the last part of Run It Right. So Run It Right has 3 phases. It's investigate, implement, and then monitor. So investigate, HTS did, implement the measures there, and then monitor is the verification of savings. So you can do 2 streams. We can put on a remote meter reader. We'll connect it and get pulses from your gas meter, and then we will take 12 months of data post-retrofit and then compare it to the baseline and then try to get a savings number there. Currently, there's no reward for savings, or there's no penalty for not achieving savings. So it's just an implementation incentive and setting up the monitoring. But we do at the back end monitor for savings, and we will claim savings at the end of the year if there are any. So the EMIS, so we can do that side of it. The second part of it would be the customer gets their meter upgraded, has the same, you put on a wiring harness and a Zener barrier, and you port into the Enbridge port, and you can get that pulse connected to your own BAS or your own EMIS, your Energy Management Information System. So if you do that, the cost is around $1,100 or $1,200, and we pay $1,000 of that to the customer. And one thing we like about that is that owners and energy services companies or whoever's monitoring have the data there, have the pulse there. It's kind of, the program, while it's focused on operational things, it's also very good to look at what your gas data is doing in real time or with the 15-minute intervals. So you get that more granularity of data for this program as well. So like I said, these guys got $10,000. We're going to do 12 months of post-retrofit. The goal is 5%, and we'll see how it goes. So it was a good project this year. And that's it for the case studies. Back to Zig.
We'll spend a few minutes talking about, just to wrap up before we get to Q&A, the new world that we live in and how this affects things on the gas side, and certainly how it changes the equation for energy efficiency and retrofits of reducing gas consumption. So it started last year, or sorry, at the beginning of this year. GHG emissions are measured in equivalent, tons of equivalent carbon dioxide. And each emitter basically has a cap and an allowance that they can then trade for if they go over or under. And it collects these funds. I believe it's expecting to collect about $8 billion annually for the express purpose of feeding back into the marketplace for further GHG reduction strategies and programs of just about every size and shape. Some of you may be familiar with the announcement that the government made last year around the Green Investment Fund, which was a wave of over $300 million of programs targeted at residential, commercial, industrial customers, specifically on the gas side to lower their consumption. So residential customers could receive rebates on free thermostat or rebates on smart thermostats. Commercial customers, depending on the size and sector that they were in, could qualify for like retrofits of certain kinds, and industrial customers were targeted with more of like a active energy management strategy program. So they've, in their wisdom, determined that one credit is equal to 1 ton of equivalent CO2. So keeping it very, 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 very simplistic. So the obvious implication of this, if we're talking about the gas side of things, is that you now pay more for natural gas as an emitter, burning natural gas for various purposes in a commercial building or an industrial building, now costs more because of the implicit hydrocarbons in natural gas, resulting in greenhouse gas emissions when they are burned. This is particularly important on the gas side of the energy equation. Ontario's electricity energy mix is relatively clean, so the CO2 per kilowatt hour is very low, expressed in equivalent kilowatt hours, an order of magnitude, like several times lower than on the natural gas side. Most of our customers don't really have facilities with emissions over 10,000 tons of equivalent carbon dioxide per year. Regardless of the one that you fall into, there are ways that we can help reduce your cap and trade costs by participating in our energy efficiency programs to lower your absolute gas consumption. So let's take an example of an office building. So here we have yet another customer. They're paying 25 cents per cubic meter of gas, which is what the overwhelming majority of our commercial and office building customers pay. They use almost 350,000 cubic meters of gas per year. So the rate in 2017 that they're paying per cubic meter of gas is almost 3.5 cents of per cubic meter of gas that's consumed. So before cap and trade, they were consuming $86,000. They were paying $86,000 a year for that consumption. You can see it's a pretty significant increase in their gas costs year over year after cap and trade has been implemented. It's costing about $13,000, a little more than that actually, per year extra for the same energy consumption because you're now actually internalizing the cost of the greenhouse gas emissions that are incorporated in that. These are at 2017's rates. 2018's rates have been filed with the Ontario Energy Board. We were expecting approval of the interim rates actually by Friday. We haven't received them yet. But they come in at, it's like 0.035 something. So it's roughly 7% more than the 2017 rates. If I can do the math. So on $13,000, you're looking at like almost $1,000 in 2018 using this example more. So in 2018, that number on the bottom would be 98,600 something roughly. So let's say we have a customer who wants to replace 3 boilers at 85% efficiency. They're not even going to condensing 95% efficient boilers. They're just replacing, let's say, like old clunky atmospheric boilers that are on their deathbed, and we're providing an incentive against that. So they're going to save 17% of their consumption. Pre-cap and trade, that's $15,000 a year of annual savings, which can then be factored into the payback, the simple payback to determine go, no go. Let's say you're Cadillac Fairview and you don't want to even consider anything that's more than a 5-year payback. Okay, fine. In the new reality, you're now saving more because gas now costs more than it used to, and it moves up the value chain closer to what electricity is in terms of what's affecting your bottom line. So there's an extra $2,000 on the table now that you're going to be realizing in savings from abating that cap and trade cost. And again, times that by 1.07 next year. So now that works up to like 2140 or something like that. So it just becomes a little bit more compelling year over year to consider your gas costs and how to reduce these costs. So Enbridge would provide, in this scenario, let's say almost $10,000, and you're going to save almost $17,000 a year. So in this new paradigm of the ROI, the project saves $17,000 a year. We don't actually have equipment costs, but you could easily, just do the division and figure out what the simple payback would be. This is a very convoluted slide, but it provides essentially a snapshot of, depending on the tranches of customers in terms of their overall gas consumption, what cap and trade means. And cap and trade, you don't actually see a line item on your gas bill, which is, everyone just loves spending time, with sipping brandy and reading their gas bill, I'm sure, in the winter months. But cap and trade is actually integrated into the delivery charge of your gas bill. So it isn't spelled out on its own line. But as an illustration, the typical home, a single family detached home in Enbridge territory, uses 2,400 cubic meters of gas per year. Obviously, that's varies hugely depending on occupancy, the time it was built, where it is, blah, blah, blah. But that would mean about $80 a year to that home. All the way up to the largest industrial customer using 70 million cubic meters of gas per year. That's going to mean $23,000 on the bottom line in cost, in additional energy cost. And so all of a sudden, you have a $23,000 per year incentive to look at your gas consumption and ways to reduce it. Somewhere in the middle, you would have medium and large commercial customers using anywhere from, let's say, 50,000 cubic meters per year or 100,000 cubic meters per year for a big box, Costco, Walmart, Canadian Tire, up to 500,000 cubic meters a year for a medium-sized office tower. maybe more than $1 million for the biggest ones
Yeah.
per year. Yeah, so the impact of cap and trade can be anywhere from $2,500 to tens of thousands of dollars, depending on the volume of gas that's being consumed in that facility. We're not going to spend too much time on this, but essentially, the new reality is gas costs a little more. So in the past, it has taken a back seat to electricity because on the bottom line, it isn't nearly the impact on a dollars basis, even though on a pure joule basis, most commercial buildings in Ontario use more energy to heat the building and heat hot water because we live in a cold place. Gas has been cheap for a very long time, but it is the primary driver of greenhouse gas emissions in the province of Ontario because our electricity is very clean now. And so this is the new reality we live in. Whether this goes the distance in terms of political winds changing is sort of beyond what we would comment on. But I think it's safe to assume that this is here to stay, and it would be prudent to at least consider this as a worst case scenario for your embedded energy costs on a go-forward basis. And you can assume that the price of greenhouse gas is going to increase year over year to really create some incentive for customers to look at gas on an equal footing with electricity when looking to reduce their energy costs. That being said, I would not expect the price of gas to really do a hockey stick like it has on the electricity side. There is a fairly stable and large supply of natural gas in the province of Ontario. It does get adjusted every quarter according to demand and other factors in the distribution network, but it has been stable for a long time, and we expect it to remain stable for a long time. So we're basically at the end. We've spent a lot of time, imparted a lot of information. If we could impart you with 4 words, there's $100,000 per unit, per project available on the table. And if we could leave you with 4 words, it would be call Enbridge and free money. It's really, really, really that simple. And if you could take away nothing else from that, it's that the money that's available from Enbridge can go to make business cases sweeter and get them over the hurdle to a go, no-go decision. And you can pony up from the electricity side as well, and just to make that payback even better. These are the deadlines at the bottom for our 2017 program. So equipment should have been installed by now, and we would need all the paperwork for any retrofit projects by December 8th, which is next Friday. That having been said, if for whatever reason equipment hasn't been installed by this point, but you'd still like to participate in the programs, you can still apply, and we would put those projects into an accrual and pay them out and process them at the launch of our 2018 programs, which would be in the January-February timeframe and look very similar to what we have in 2017. So just a few FAQs, then we'll open this up for questions because we've actually filled this time quite nicely. There are a few conditions to pre-qualify for a project. We can support a wide list of measures, but please contact Enbridge. There's no formal application that you need to fill out. There's nothing onerous like that. We provide a turnaround within 1 to 2 business days to let you know whether a project can move forward or not in terms of getting an incentive. Yes, absolutely, apply for any and all financial incentives available, whether it's dual fuel savings on the electricity and the gas side. If you're installing equipment where you're moving from electricity to gas and the efficiency of the equipment means you're going to be lowering the expected gas load than you would otherwise have, yes, we can provide financial incentives for that. And yes, we have a large portfolio of financial incentives for new construction projects. And if you miss the deadlines, you can still most likely get incentives.